the beautiful northern studios of Way Happy, this is Mr. Meyer and section 2 for writing linear functions. In other words, making the equation of a line. How do you make an equation of a line? You got some data and you want to know an equation of a line. Well, one of the most popular things that we know is something called slope-intercept form. And you remember that probably from the last video or in class. That's the y equals mx plus b form. That is called slope-intercept form because we have a slope right here as the letter m, and we have an intercept right here, which is the b, which is the y-intercept. So your job is to come up with an equation as best as you can by filling in those two numbers, filling in the slope and filling in the y-intercept every single time. So sometimes it's kind of easy, kind of nice. I can look over here. If I understand what a y-intercept is, this is the y-axis right here. And if I'm going to intercept that y-axis, that means I'm going to cross it. I can see that we're crossing that y-axis right there at what appears to be the number 1. So just looking at a graph, I can see that b is 1, right? It's positive 1. It's either, if it's up, it's positive. If it's down, it's negative. So look at where 0 is. That's just a number line. That y-axis is just a number line. What number is it crossing at? It is crossing at 1. That's my y-intercept. Well, then what's my slope? Well, your slope, what you'll try to do then is try to pick any 2 points where you can count the rise over the run. And luckily, they did a really nice job here. They marked points for me, that y-intercept, and look, here's another one. So I can count the rise that we have. So this rise looks to be 1, 2, 3 units long. And this run right here looks to be 1, 2, 3, 4 units long. So I apparently have a rise of 3 and a run of 4. Now the only thing I got to worry about is it positive or negative? Remember, as you read a graph from left to right, if it's going uphill, it's positive. But if it's going downhill, it's negative. So I'm going to throw a negative out front. And now I can make my equation. It said write the equation. It didn't just say find those two things. It said find the equation. So y equals m, which is negative 3/4, x plus b, which is 1, and you jump up and down. You have now written the equation of a line in slope-intercept form. Good job. Nice work. Now, what is the slope formula? The slope formula, as you saw on a graph, I just counted it, right? I just counted how many spaces I moved. It was easy. Well, what if they're really far away? Would that scare you? Well, that's what this formula is for, and it's kind of very logically built, right? You have a point that you plot here on the graph thing and a point that you plot here. And if you want to count how much they rise, just subtract the y's. If you want to count how much it runs, just subtract the x's. And so remember, it's rise over run. So subtract the y's, find the difference between them. That's how much you rose. Subtract the x's, find the difference between them. That's how much you ran. And that is your slope. And that's how somebody once, long time ago, came up with this beautiful formula that we still use all the time right here. Now, does it matter if it's y2 minus y1 or y1 minus y2? No. But what does matter is you stay consistent. If you did y2 minus y1 or the second point minus the first point, then you have to do x2 minus x1, right? You could do x1 minus y1 and y1 minus y2 over x1 minus x2. That would also be legitimate. So now that you know slope formula and the equation for that, here's, I give you 2 or more points, you tell me the slope of these lines. So you can use the formula or you could graph it. It really doesn't matter. But I'll use the formula since that's what we have. So the slope formula is y2 minus y1 over x2 minus x1. I'll call this the first point, so that's x1, y1. I'll call this the second point, x2, y2. And now I will just plug it into the formula. Look, the y's are be negative 5 minus 1 over 2 minus a negative 1. Or what is that? Negative 6 over 3, or a slope of negative 2. And you could check it by graphing. You could graph negative 1, 1. Like, where would that be? I'm kind of curious. Negative 1, 1 is like right here. And the second point is 2, negative 5. That's like way down here. Does that look like it's a pretty negative slope of 2? Yeah, I could almost believe that, right? At least I know it's negative, so I know the negative is right. And I could draw it all out with tick marks and actually just count it to make sure. But I'm not going to because I trust my math skills, and we'll see. All right, what about B? B is a bunch of points. So if they're all on the same line, I should be able to take any 2 points and subtract them. You can pick the first and the last, you can pick the second and the third, you can do the first and the third, pick whatever you want. I'll pick the middle two, say. So what I'll actually do is I'll call this point 1. So this is my 1s, and I'll call this my 2s. And so here we go. Slope is y2 8 minus 5, because that's y1, over x is 12 minus 8. And the slope there you can see is 3 over, was that 4? So the slope is 3/4, positive 3/4. Again, I should be able to subtract that from any of them. Do the 11 minus 8 over the 16 minus 12. Hey, you also get 3/4. So it shouldn't matter which ones you do. What about if they give you a line? So here we gave you points, we found the slope. They gave me a table, I found the slope. Now they're giving me a graph, I can find the slope. Why? Because I'm just going to grab 2 points. I'm going to pick any 2 points I want. Like I see this point right here, the y-intercept, that's the point 0, 2, negative 2. And I see this point right here, which is 3, negative 2. And I'm going to go ahead and I'm going to find the slope for that. So again, using your beautiful slope formula, y2 minus y1 over x2 minus x1, I will find that slope. So negative 2 minus a negative 2 over 3 minus a 0, you are going to see that I have a negative 2 plus 2 over 3, or in other words, 0 over 3. And as we know from algebra, 0 over anything is always 0. And be careful, anything over 0 is always undefined. All right, let me ask you a question, and I will be right back. All right, nice work. Now, on to example 3, where they give us a bunch of data points. We've already seen that we can actually make a slope out of that. So why not let's find the equation. So again, just for fun, I went to Desmos and I plotted all those points. You can see them, the red one and the blue one, the green one, and the looks like a purple one. Plotted all those points. They are in a nice straight line. So what is the equation of that line that passes through there? So again, I can take any 2 points. I will probably pick the 2 simpler ones. So again, I will do the slope is y1. So let's go 1 minus a negative 5. The y's are subtracted. And then now let's subtract the 8. The x is 8 minus a negative 8. So what do I get? I get 1 plus 5, that's 6. And 8 plus 8 is 16, or also known as 3/8. And I have that part of the equation. Now I need the hard part, I think, is the y-intercept. Well, we know the equation is y equals mx plus b. And we know that I have found the slope. I found slope is 3/8. So it's y equals 3/8 x plus b. But now how the heck am I going to find b? Well, good news. We have a bunch of x's and y's right here that we can plug in anywhere in the equation. In fact, I'm going to take that last point and I'm going to plug, because that point has to be on this line. That's the whole reason I'm making this equation, is because it's an equation that represents those points. Well, all those points have to be on that line, even the last one. So I'll let y be a 1, and I will let x be an 8, and I will solve for b. Oh, that was a really good choice, because look, the 8's cancel. When you divide by 8 and multiply by 8, they will cancel, and I'm left with 1 equals 3 plus b, and now I'll subtract the 3 over, and oh my gosh, I figured out what b is. So now they want this equation, piece of cake, y equals, what do we got, 3/8 x, and then plus b, or minus 2. And there is the equation of the line that contains all those points. And just to make sure we go back to Desmos, I already typed it in, and boom, there it is. And look, it hits every line. Nice. All right. What else do we got? What about this? They want you to express rent. So we have selling price here. You sold, I don't know, what do you want to call those? Like computers. They are computers that sold for different prices, or you could rent them for these prices. Now that rent is per day, making stuff up. And so there's a selling price and there's a rental price for that stuff. And so, what if we have this model, maybe in the future, we're going to buy more computers and the prices are going to change. You're going to have a $200 computer and a $400 computer. We need to know how much rent to charge. We can't just make up a number. So we want to stay consistent with our data. So again, I would like to make an equation. I want to express rent as a function of selling price. In other words, I want to be able to tell you the rent if I know the selling price. That's all that means. So let's make this a table. What's stopping us from calling the selling price the x's and the rents the y's? So we'll call the selling price the x's, the rents the y's. Just think of them as points. So this now becomes the point 75, 9, right? And I could plot that. And this becomes the point 90, 12, and I could plot that. And in fact, I'll use those 2 points to make my equation. So here we go. I'm going to do slope is subtract the y's. So 12 minus 9 over 90 minus 75. So what is that? 3 over 70, what is that? 15? Yeah. And so that's 1/5. So there's my slope. So now my equation becomes y equals 1/5 x plus b. And now I would really like to find out what that b is. Well, I can pick any one of these points that I made. I'll pick the first one again. So the y value is 9 and the x value is 75. So 9 is equal to 1/5 of 75 plus b. Now, what is 1/5 of 75? Well, 10 times would be 50 and 5 times would be 25. So it must be those two numbers together. So it must be 15. So this is 9 equals 15 plus b. And now I'll subtract the 15 over and get -6 equals b. Now I have an equation. So I have y equals 1/5 x minus 6. Or maybe I could make it a little better by saying rent is equal to 1/5 of the selling price. Let's call it S minus 6. Maybe S is not a good choice because it looks like a 5. Maybe I should use P for price. Hope you don't mind if I change that because that would make me not like it. P for price. So there you go. If you take 1/5 of the price and you subtract $6, that's how you get the rent. And now I have an equation that will help me every single time. And look at the next question. We have a property. Oh, I guess these were properties. We have a property that has a selling price of $230. Oh, this must be Monopoly. We have a property of a selling price of $230. How much will the rent be? Well, the rent is 1/5 of the selling price, which is $230 minus $6. Right? And so now I got to figure out what 1/5 of 230 is. Well, what is that? That's 5 goes into 200. I think that's 40 times, and it goes into 36 times. So that's going to be 30. No, did I say 40? 46. 46 minus a 6. So that means the rent is going to be $40. Now I can tell everybody, hey, the rent is $40. And they're like, nice work. All right, let's finish this up with the last two things that I want to talk about. And that is this idea of parallel lines and perpendicular lines. Parallel lines you see in the first graph. They are two lines that never touch. They have the exact same slope. That's the rule. Whatever your slope is, they're the same. And so you may or may not remember that when we talked about how we were going to get slope, it was the thing in front of the x value. So look at this example right here, the slope is 2, right here the slope is 2. And since they are the same, those lines are going to be parallel. Now there's a chance of the same line, that's when these two things are the same. But if they're not, then these are just parallel lines. What about perpendicular lines, which means they cross at 90 degrees? Perpendicular lines have the same thing with their slopes, but a little interesting. They are opposite reciprocals. You can see that right there. So if one is -3/2, then the opposite would be positive, and flip it would be 2/3. That is the reciprocal slope. So if you want to have parallel lines, you give them the same slope. If you want to have perpendicular lines, you give them opposite reciprocal slopes. So what do I have here in my last two questions? I want to be parallel to this, and I want to go through that point. Not a problem. I don't have to find the slope because I know the slope is 1.8. Why do I know that? Because I want to be parallel. Now I want to go through that point. Remember this part? I have the equation 1.8x plus b. I want that equation, but I want to know what b is. Well, that's why they gave us this point. Here's the x and the y, just like we were doing earlier. Oh, would you stop? X and the y. Go away. That's your x and your y. So I'll plug them in. I'll be like 2 is equal to 1.8 times x, which is 5, plus b. Sorry that's so sloppy. What is 1.8 of 5? That's like 9. So 2 equals 9 plus b. So b is -7. And now I have the equation. Why are these things keep popping up? y equals 1.8x minus 7. There is your equation that is parallel to the other line, this one, but perpendicular. I'm sorry, but going through the point 5, 2. And I think I'm kind of done. But perpendicular, let me at least set it up. I would do the exact same thing, except for I would mess with the slope. So I'd be like, all right, the perpendicular slope would be 2/3. So my equation would be y equals 2/3 x plus b. And now I'm going to plug in x and y. All right, I'll finish it for you. -2 equals 2/3. The x value was 9 plus b. That goes in pretty nicely. That's a -2 equals 6 plus b. Subtract the 6 over. B is -8. And lo and behold, y is 2/3, the slope that we needed, -8, the y-intercept we found when we went through that point. Nice work. You guys have a great day. Stay happy, and I'll see you tomorrow.